Well, okay, good afternoon, Bengaluru, and good afternoon, Cypher attendees. I am Karthik. I work for LinkedIn, and I am the tech lead of the product engineering team. Recently been working a lot on generative AI, building agents. So I'm going to talk today about real-world lessons we've learned from actually building and launching production quality agents. Okay, so that didn't work well. Okay. So the agent we have out there is called Hiring Assistant. It helps recruiters hire more efficiently. So you can see Ryan Roslinski, our CEO, announcing this in 2024. I'm somewhere there in the front. You can't see me. You've got to believe me. You've got to take my word for that, but I'm there. So what exactly does Hiring Assistant do? So Hiring Assistant speeds up the job of recruiters. And these are some stats from our charter, which is like a pilot we did with customers. You can see that people are viewing far fewer profiles, are seeing higher in-mail acceptance rates, and are spending a lot less time on applications. We sincerely believe this brings the joy back into recruiting and saves recruiters time by allowing them to focus on the more strategic aspects of their job and delegating the more tactical aspects to this hiring assistant while being in control. So I'm going to talk about how we built this and some lessons we've learned. Hopefully, it'll be useful for you as well. So the first thing is you've got to modularize your agent design. Separation of responsibilities is very, very important. So the way we architected our agent is we actually have a hierarchy of agents. It's not one agent. It's like a hierarchy. So we have a top-level supervisor, which have sub-supervisors, which go on to agents under the hood, etc. It's almost like the way an org chart is structured, if you think of it, in the corporate workplace. Agents also work quite a bit like that. So we have a top-level supervisor. We have agents for sourcing. We have agents for calibration. We have agents for in-mail reach-out. We have sub-agents. So it's like a hierarchy. So the control flow inside each agent, super high-level view, looks something like this, right? You just give it a prompt. It goes through a planning phase. It creates a task, it runs in an iterative loop, and it keeps running and running and running till it gets an outcome. Sometimes it won't get the answer. It'll have to replan. Sometimes it'll have to ask humans, and we'll see how we architect this later in the presentation. So the other important thing is to build and expose skills to interact with other systems, because the entire job of an agent is to get it to do work. In order to do work, it has to interact with other systems. So how do agents do things? They do things with skills. You can call these as tools as well, but skills are slightly different from tools, and we'll see how. So the typical tool definition is function calling, right? But skills are more. Skills encapsulate the what and also the how. And they can take various shapes and forms. RPCs, database queries, prompts, even other agents. We try to model agents as skills. An agent asks another agent to do some work. MCP is emerging as the de facto standard here, pretty popular. So one of the things which we realized early on, and we built the skill stuff before MCP came about, and right now we also support MCP here, is that we need to invert this, right? In the sense that you try to register all the skills in a registry, and after that, the source of truths expose the skills. Rather than have agents have the skills, the source of truths have the skills, and the agents identify these skills by calling out to the registry where all the skills are advertised, and they invoke the skill. Now, the beauty of this approach is that it actually provides agency. It may be very tempting to hard-code stuff in there, but no, you don't give the system agency then. In order for the system to have agency, it needs to be able to seamlessly discover these skills, which is where the skill registry comes in, and invoke them. Cool. Then, really important, you need to have very good memory, right? Otherwise, you can't remember and personalize your interactions. And people have this as a baseline expectation. In fact, this is one of the things we learned from our early generative AI product experiences, that you need to have world-class memory. So if you look at the control flow, the LLMs themselves are fairly stateless, right? So you need this additional layer to remember your interactions. And this is how it works, right? Your responses are updated, and you retrieve it later. Very simplistic view. But in order for this to actually work, you need to have scoping and layering. So at the top level, you have what we call as working memory, which is only for that particular session in the form of your conversation history, the context of your particular task, etc. Below it sits long-term like memory, which is way beyond that session. This can be episodic, which is across a series of related sessions. It can also be procedural. This is very powerful. In an open-ended agentic system, you do not want to run the LLMs again and again to do the same things over. If you remember the task trace properly, you can reuse it as opposed to recomputing it. So this adds like determinism and also saves on compute cost and latency quite significantly. And at the bottom, you have what is called as collective memory. It typically spans across users, spans across like sessions. For example, in the case of the hiring assistant, it could be that, hey, recruiters at company X follow this sort of a process. It's something which we learn over time, and we store here. Cool. Then you got to build for scale, because ultimately, this is a system running in production. And the way to build for scale with decent time to market is to opportunistically reuse what works. So how do you plan and execute tasks at scale? Classic distributed systems problem, just horizontally scale it, right? But you got to be careful, because your classic distributed systems problems return with a twist. What's the problem and what's the twist? Well, the problem is the same, right, in any distributed system. You got to maintain distributed state consistency spread across different machines, potentially running in different regions. You also got to account for hardware downtime. You also got to account for ephemeral failures. But more importantly, in an agent, you're doing all of this with a non-deterministic workload, which is the twist. It's way more complicated than running a regular distributed system. So the idea is, rather than resolve all the problems from ground up, build atop battle-tested systems. So you can see some of the systems we use here. We've added this like layer atop to work well with agents, but these are all well-tested, production-grade systems. The other thing is to pick the right model, to optimize for the right constraints. Now, you may think by the model, I mean an AI model. Well, like yes and no, because sometimes you may not even like need an AI model. If you have procedural code which does not need any reasoning, don't throw a model at it. Just write code. And even if you do not want to write that code yourself, you can get a model to spit that code out for you. Way cheaper, way faster, way more deterministic. So don't use a model for everything. And even if you want reasoning, look at your quality, scale, and like latency constraints when choosing the model. Do you want a commercial model, or do you want a custom model? So this is like the model customization, like pyramid or hierarchy of needs, however you want to call it. So at the way at the bottom is what I recommend everyone start off with, right? Vanilla prompt engineering, retrieval augmented generation, maybe cache augmented generation. That's it. This should satisfy most of the use cases. Now, if that does not work, you go on to post-training, where you take an existing model and you like fine-tune it. And again, there are different like techniques here to do like fine-tuning. Something which is emerging quite a bit in the world right now is fine-tuning, which is based on reinforcement learning. Pretty popular. Now, if that also doesn't work, you can do more, which is you can go and do pre-training, right? Which is effectively you train your own model. Again, you may be very tempted to say, oh my God, I'm going to train my own model from scratch. No. Don't fall into that pitfall. It's really expensive. All the models are evolving fast. Start at the bottom, go up the chain, only if you have a need. Human in the loop. Agents aren't fully autonomous yet, as much as we'd like them to be. So you have to design for human in the loop. Now, like, what do humans do in the loop? Well, I guess we are still useful, right? So the first is they ensure accuracy. Then they add control and oversight, especially for sensitive actions. It's very important. And the third is active learning techniques, where the human is providing feedback and the agent is learning from it. And it gets better over a period of time. Good agentic systems learn from the human. they learn from the environment, and they improve over time. So it's very important to build for human intervention. Classic compute is extremely synchronous. It may be like distributed, but it's still synchronous because systems are talking with systems. Here you have a human in the middle who can interrupt, and it's really hard to put a SLA on humans. So you started doing something, you realized it's unclear or you need approval, you reached out to a human. You have to wait for the human to respond. And after the human responds, you have to continue computing. What this means is that you absolutely need to have a system which can store state and which can resume it and start executing after an arbitrary amount of time. All your systems architecture, your UI, your control flows have to account for this human in the loop. So humans can respond whenever they want. You have to use UX patterns. Classic pattern is to send a notification to a human and wait for the human to respond. And you have to build asynchronous event-driven compute. You cannot assume synchronous compute. Evals. This is just like testing. Only thing, you're working with a non-deterministic system, so you have to have very rigorous evaluations. So the idea is you have to combine humans and agents to utilize the best of both. Humans are good at defining policy and scoring things initially to say, hey, you know what, this looks good. And after that, you throw some automation at it to scale it out, right? Humans are also good at capturing nuance and subjectivity, something which agents still struggle with. So generally what we do is we have the humans capture nuance, provide guidelines, and again, we automate it at scale, right? And all of this, since you're operating on a huge data set, you need really good tooling to visualize the results and to take action. You want to see aggregate trends. You want to see edge cases. You want to see what broke down where. Otherwise, it's like hunting for a needle in a haystack. It's very hard. So evaluations are way more than functional quality, right? You have to look at trust, safety, security, responsible AI, especially when doing something as sensitive and important as recruiting, which is primarily what our agent is doing. We need to be extra careful. Also, you've got to build for optionality. If you look at the space, it's moving really, really fast, right? So you've got to be nimble and flexible, which is try to embrace open standards. As I said, there was no MCP when we introduced skills, so we built skills. Right now we have MCP, so we are trying to embrace MCP. And also try to buy or adopt rather than be tempted to build everything in-house. And last but not the least, you do not want to invest in expensive refactoring of your application when the space is moving so fast. So invest in the right abstractions to isolate your business logic so that you can move as fast as possible. So this image was generated using ChatGPT, but it shows an elephant dancing, which is how you should be thinking of architecting your systems. It's a pretty complex system, but you got to make it nimble and sort of make it dance. And that's it. I have my QR code in there if you want to connect with me on LinkedIn. Thank you.